Greetings. I'm Steve, and I'd like to thank you for joining the Architect and the Executive podcast, where we discuss technology, philosophy, leadership, personal development, and much more. The theme for each episode varies as we endeavor to examine various topics from our unique points of view. I hope you enjoy this episode of The Architect and the Executive. In this episode, we dive into the topic of defensive programming, with a focus on how to be defensive in a low-code or no-code platform. We're discussing a slide deck Imran created, which is shared on our website, The Architect and the Executive, in the podcast section for Season 3. We hope you enjoy this episode of The Architect and the Executive. Hey, Imran. How's it going today? Welcome to another episode of The Architect and the Executive.
Hey, Steve. How are you doing?
You know, it's been a great week, short week. Memorial Day week this week while we're recording, but still super busy at work, just like always. Glad we're having a chance to get together, though, to talk about defensive programming. For those of you that don't know, defensive programming is the idea of writing code with the intention of handling the unintended, the unforeseen, the things that you're not thinking about, the bugs and the errors that might come in, and trying to set up your code, your application to deal with that in a way that allows you to fail gracefully if you have to fail.
Right, and I'm glad that we were able to get into a little more technical topic this week, right? We've had some cool topics the first couple of weeks, but this one is really important because it highlights how important it is, the decisions we make as developers, right? Sometimes they can seem arbitrary, and sometimes they have really important impact on things, right? The more and more our lives are programmed, the more and more those decisions made by programmers are, kind of controlling the narrative in which we can live.
That's a great point. I don't think most developers, when they're sitting down to write the next app for tracking your tasks, right? Nobody thought about, how am I programming my life while I'm writing, Todoist. But there's still other things that are pretty important. I don't think about that when I write code, but it's still important, and the things that we're doing and what we need to do are clearly critical for the day, as we think about our programming life. And there's a lot when I think about defensive programming, right? The goals of one, just trying to write an application that's correct, right? That's kind of that first thing. Do the right thing. Maybe not even an application. We'll go down to the feature level. Try to write a feature that's correct, and that it's clear, and that it's readable, and that you can go back to it. I've always heard people say, write code that's easy enough to understand that you don't need documentation. And I've been there. I've written some code that I really wish I had documented later. And I've done some where I've spent a lot, but I'm not certain that that's the key to writing defensively, right? You may need to lay out why you built in a precondition or something like that. I think we're fortunate today, as part of the materials that we'll share in the show notes. We have a slide deck that Imran's put together. It'll be linked on thearchitectandtheexecutive.com. For this episode. You'll be able to find it. There's a lot of materials in here. Imran, I think you've done a wonderful job setting this up. Thank you. In this episode, we're going to talk through what those are, and we'll be descriptive about what it is we're looking at. But if you have a chance to also watch this or listen and watch and view the slide deck too, I think you'll find some great value in that. So let's jump right into that. All
right, yeah. So, this concept came about as we, found that there were some things that we could do better, right? Some programs that were failing for things that they shouldn't have failed on, right? Like unchecked values or empty values and things like that in an import, things that we caught. And then those things not, the queue process that's, handling that import itself, not being able to take care of unhandled exceptions. So we had this stuff where things were being thrown at the application that weren't expected, and they were detrimental, right? And so, you started bringing up this concept of defensive programming and the idea that something like that being thrown at us shouldn't bring us down to our knees, right? We should be able to handle it in a way and keep moving on. And if itself is an exception, that's the whole point, right? Handling exceptions. So I started looking into defensive programming and wanted to get together with the team and really be able to translate what that meant for us, especially in a low-code environment, right? Because a lot of the materials that I found online were very specific to a language. I didn't find anything that was just like, here's defensive programming. It was really more so, here's defensive programming in C Sharp. Here's defensive programming in Java, right? As I was going through Udemy looking for courses to watch, right?
Sure.
So I found one and I started watching it and I decided, okay, I can look at this and I can extrapolate the tenets of defensive programming and then put together something that relates more to what we do on a day-to-day basis that might make sense, right? And so that's where this came from. And as we're looking at these slides and going through them, we'll talk about what they mean and how it applies to our life, right?
Yeah. Well, I think that's a really important piece. This is primarily, as we look at things, it's around how do you be defensive in a low-code platform, right? We use Mendix for a lot of our applications. It is different. It does require some different kinds of thought. While it's still the same concepts of make sure that you're anticipating what's coming. You mentioned an import that we have that doesn't do a lot of great error handling. So if we get bad data, it can find, ways that there's an uncaught exception that might kill off that whole queue. And we have people that are constantly watching that queue, looking for the latest updates. And if it hasn't updated in 2 minutes, they're sending us a message, right? Like that is the expectation that every 2 minutes this data is updating. And when it doesn't, they're on us. So it's been that especially has been a point of real focus for us, is how do we improve what we're doing around data we clearly don't control.
Right. And so as we get into this, one of the first things that came up was, what are the goals of defensive programming, right? As we look through this, of course, as you mentioned, correctness. The program has to do what it's supposed to do, right? Whatever we wanted it to do, whatever it was designed to do, it can do that. And then clarity is can it do what it's supposed to do concisely, right? Is it very, efficient in the way that it's working? And is it easy to understand as you're looking at it? And that leads us into the next one, which is readability, right? Could someone else, or even yourself, weeks or months later, come back and understand what you wrote, right? What you made there, right? Are you annotating things? And, and we'll look at examples of that. And then, of course, the last one is bug prevention. We want to foresee, we want to be able to design better, and we don't want to have bugs in the first place.
Agreed. And I think, when you think about readability, you mentioned annotations. I think that's a best practice for Mendix that's not well known. That's adding in information about why you're doing something around a microflow is, I know, something we have in our code base, but I'm not sure it's everywhere. And I think that's something that maybe as a call out or something we could do, we could show an example of what that looks like. I think Mendix developers, especially, and anyone in a low code environment would benefit from kind of adopting that annotation idea.
Right. And so then as we look at, what do we want to do, we also have to look at what don't we want to do, right? So when things we don't want to do are we don't want to code for speed, right? We can speed something up after we've written it and figured out how to make it work, right? We got to hit some benchmarks, figure out what the bottlenecks are, then we figure out where we can optimize. We don't know those things before we started building in the first place, right? And that takes us into this, concept of early optimization. We can optimize if we don't know where to optimize. It gets rid of clarity if you try to do it too early, right? And then it also ruins any of your bug prevention mechanisms or any concept of readability. It ultimately becomes a waste of time.
Agreed. Yeah, 100%. We spent, on a project that I worked on years ago, spent a lot of time figuring out how to implement a caching engine before we had built out the whole process. And it turns out that we cached a lot of things that weren't at all important. And we spent a lot of time after deployment going back and finding the things that were actually really slow that needed to be optimized over and over again. It was, you can't do it early. You need to see how the app's used. You may think you know how it's going to work and how it's going to be used, and maybe you'll get it right. But if you don't and you prematurely optimized, you wasted a lot of time.
No, and you don't want to be too clever, right? You don't want to be novel, and you want to make sure everything you're doing is clear and concise. Mendix provides some great tools in Studio Pro to do this, right? When we're designing microflows or long-running actions, the idea is get in there and make it work. And then there's ways that you can grab subsections of it to extract subflows and then create these reusable functions as you're building, right? And then so once you get it out there, then it makes it easier to break it down. But if you try to make it in that broken down way from the start, like you might get into a model and see, a senior developer has built this way, and if you're thinking he's building that way from the start, that's wrong. He's likely, if he's smart, building it as one big thing, making sure it works, and then finding out how he can break it down into smaller reusable pieces. Right.
That's the refactoring piece, right? That's really what that whole is. There's an art to refactoring things. Right. Once you have them working, then how do you break it into smaller pieces, or to your point, reusable or more manageable chunks of code, right? Instead of 18 different actions in a microflow, maybe you break that down into 4 and, hide the other ones.
Right. And so in slide number 4 of the slide deck here, what we're looking at, the idea is that you don't want these long blocks of code, right? And so one of the things that you're looking at here is on the left side, these are 2 microflows that do the exact same thing. And they were both made by me. One, obviously, lessons learned, right? So the first one, I made it work, and it was in an app, and I had less time on it, and it was my first time doing something like this. And so in this way, right? And so I made it work. And because of the time constraint, you remember this one was one we had like a 2-week or less MVP on it. And it was the thing that we used to sync MLS data. And, we put out something that could sync really quick and then provide the internal API to respond. So we're taking that RESO org data and making it available to all our services internally.
I remember that stuff. Yeah. And so, that was I don't think you even had 2 weeks on that. Yeah.
I didn't. And so, I didn't get that chance to go through and do that second layer. Now, the one on the right was another service you designed, and it was likely the relationship service, I think. Maybe
could
the system
be
service. One of those two. It provides similar thing. It takes some GET parameters and provides a response to an API call, REST call. However, the one on the right is a little bit more modularly done. I took those repeatable blocks of code that you see, and I extracted them into subflows. And so the one on the right is a little more readable. A new developer coming into this, it doesn't look so daunting as a thing, right? And this is the equivalent of having 1,000 lines of code that you could turn into 500 or 200 by reusing pieces, having it be modular and stuff like that. So it makes it easier to read and get around.
Right. I think for those of you that haven't seen the slide deck or maybe aren't familiar with Mendix, the modeler to me, and I'm not a Mendix expert by any means from a development side, it's kind of like a flowchart builder. So think about Visio, where you put a box on a screen and you say, okay, I have this, and then you have a decision to make, and you're either going yes or no, true or false, and you're following those 2 paths. Well, what Imran's describing is that one of them is 35 different boxes, maybe more, with decisions all over the place. And the refactored version of that is 7 or 8 with 2 decisions. The other things have been moved. It is the no code, low code idea is really process driven, that you are building a workflow or a microflow in the Mendix case that lets you encapsulate your business logic into something that's really straightforward, and you can look at it and understand for the most part what it does. Again, that's where annotations help, but it's the idea of here's what we're doing, here's a decision that we're making, here's data we're going to get. It's very straightforward, but it still has all of these things that we're talking about that you need to be thinking about. Are you doing this in a correct way? Does it work? And before you go try to fix it and make it faster or prettier or in an all straight line, let's go make sure that it actually works.
Right. And even when I did the second one on the right with the 7 or 8 boxes and less decisions, when I first made it, it still looked like the first one with 35 boxes and many decisions. And then once I got it working, then I went and I used the modeler to make the subflows, because then it automatically sets up your input parameters and your outputs back into your main flow. So it's a lot easier to go through, and you let Studio Pro do a little bit of the work for you.
Oh, that's great. That's awesome.
Yeah.
So as you think about, working in Studio Pro, and I know you mentioned it here in the slide deck, the naming conventions, and how do you make sure that everybody does kind of the same things in a project, right? If you're a one-man shop, that's one thing. You can name how you want. But in our case, we have a lot of developers that get in and they're looking at things. How do you establish that naming convention or the style that you're going to use.
So, those things become very challenging, right? We have lead developers and we do code reviews, and a lot of that is a manual process. And so, we did look for a tool to help us automate that a bit, right? Something where we can establish, some of these guidelines and of best practices and be able to scan our apps. And we vetted out a couple of tools, right? We have AQM from Mendix, which provides some quality scores based on ISO standards, but it's really more of a standard type tool there. And it, you'll scan your package after the fact and get a report on it. And then we looked at Omnext, which was a tool which also does some scanning. This one allows a little bit more customizability, I think, if that's a real word, of the rules.
It's close enough.
And best practices. They've actually interacted with people from around the Mendix community to gain best practice knowledge and put specific best practices, not just general software development, but specific to Mendix, into their package. And then we ultimately landed on the ACR tool by Man Systems. We used some other tools by them as well, and so it just made sense to fall into that same suite with their digital factory. And so we tried this out, and I really like this tool. We were able to take the rule set that's in there. It's their years of experience of Mendix best practices, and it's all programmed in there. Then you can customize it, but it has things like the prefixes and things that are specific to Mendix naming conventions, things about attribute limits on entities, entity limits in domain models. How many actions do you have in your microflow? Things that aren't really relatable in a traditional coding environment, right?
Sure.
And it's designed to be a self-serve tool, which also eases the pressure off of the senior devs. So the developer can commit their code, go scan with ACR, get a report of their violations based on those best practice rules that we've looked at. And what we did is, as a group of senior devs here at EXP, is we reviewed every single rule one by one, looked at the defaults, looked at what made sense to us, what didn't make sense to us, what we wanted to tweak. And we came up with, what it lets you do is it lets you set in your own set of defaults. So now when every developer can now bring in our EXP defaults into their ACR scanning tool and scan based on that. And if we ever need to make changes to that, I can go make changes to one set of defaults or one of the senior devs as we find something new, right? And then our goal is get these violations down to 0. And it's a combination of fixing the problems and potentially saying, hey, this has to be a certain way, it's an exception, and I need to whitelist it. But those become discussions to say, hey, but they're very individual.
Is this then part of, when you think tactically, this is part of our defensive program, right? Mm-hmm. We're saying this tool, ACR, which is Application Code Review, Automated Code Review.
Automated Code Review, I think.
I think so. All we know is the acronyms. That's the important part. But it is part of how we're approaching that whole concept of how do we write better code right off the bat, right? Apply and enforce our best practices. The naming. There are some things, and I can't think of any right off the top of my head, but like a certain type of action starts with a certain letter code, right? You guys use like AK or ACT.
Right. If it's an action like an ACT, or if it's a data source microflow, it might have a certain prefix on it. If it's a calculated attribute, it'll have a different prefix on it, right? Sure. So those things kind of help us, and adds to the readability of the app, because again, this is how we know easily looking through the project navigator what does what. And then there's the folders in there, and there's a way of organizing inside Studio, and we'll have to include some links in our show notes here to the Mendix website and to some of the Studio training.
For sure.
You can definitely create an account. Doesn't cost any money, and go do all the learning. But it's all ties in, and this is how we look at it in our environment, is enforcing those types of things, right? How's your folder structure? How's your naming convention? When are you creating a new module versus adding stuff to an existing module as you're extending your domain model? And then, some of the stuff we're talking about right now is all on the end, right? This is the pre-QA but post-development phase of reviewing, right? Some of the other things we've added on the front end are a little bit more organization and unification over the architectural design with component diagrams and class diagrams, and doing more of a planning on the front end, and even with user experience and mock-ups and things like that. and getting
For
more
sure.
of a kind of a sign off from the business, like this is what we want. And for us, it's knowing what we're trying to produce and what components are necessary, where data should live, how it should flow around. And then, of course, demoing often to our business users so that we can get feedback throughout the sprint and go to QA with less bugs and be able to be
Right.
better in production.
I think what you just touched on there is a key point for anybody that does software development, whatever part you're in, whether you're in product or the business or whatever it is, having a plan for what you need to accomplish helps you think through the challenges you might have. So as we have discussions and refinements about stories and things that we're writing, that's part of being defensive. You're working through, before you write a line of code, all of the things that you know you need to do. And maybe you're going to point out some of those areas that might be problems.
Yeah.
You may find, we have to get data from this third-party system that we have no control over. Okay, well, let's look at their data. It's consistent. It's great. It's all the same. Awesome. That's great. Now, what happens when that data is bad? How do we make sure that whatever we're doing, our application doesn't fall apart because we got in bad data? That too, the planning that you do, the diagramming, the understanding of your interfaces and your domain boundaries, those are important. But most people don't think about that that's probably more of a solid engineering process than having a defensive mindset, right? But I think, and it's certainly working for us, I think that's a way that we differentiate, especially in a low code environment that we're working in with Mendix.
Right. And we still, even in a low code, we still have a concept of design patterns, right? And making sure we're applying those patterns as we go throughout. A lot of the common ones, as we're looking at slide number 6, here's a one that every Mendix developer is familiar with. It's, the creator retrieve existing, right? When you need to populate an object into a data view in order to load a page, you don't want an empty data view because that's a bad experience, right, for the user.
Yeah. And
so you always do this check, right? Create an object, retrieve the existing object, or create a new one if it doesn't exist. And that ensures that your program can go on and not stop right there in its tracks, right?
Yeah, this was one of the things we ran into as we were working in with our product folks who were trying to get in to do Mendix, and the idea that in order to show the form that they were working on, they had to create some data behind the scenes, right? Like this pattern is a great one. It's one of the few that I think I actually know for the limited amount of Mendix development that I do. But that whole idea of I want to either show you something or I want to give you a blank one to work with. That's a great point.
Right. And then another common pattern on slide 7 is the validation microflow, right? And this is where we validate data on forms and things like that as we submit them in to ensure that we're not going to break something downstream and we're getting data the way we expect, right? We check that on the front end to ensure that everything is perfect, right?
This is one of my favorite areas, and I think it's one of the places that most developers need to spend more time. You know what you're expecting. You have a model for your app, so either you're creating the data or you're getting it from somewhere. How are you building that data in your app, in the function where you need it, in that method, to be correct? And if it's not correct, what are you going to do? Right. So if you're expecting, first name, last name, street number, street address, street directional, city, state, zip, and you don't get all of that, what happens? Or, for street name, you get a number instead, right? You're expecting it to be, any lane, and you got 16th. Well, what do? Did you get a bad address? Is it mismatched? Like, how are you dealing with that? And that's a key piece of how you think defensively. What am I going to do? Because if the address is bad, can I prompt the user? Or do I just need to flag this record as not being good and have some way to review it? And I think having a pattern and a standard way of dealing with it makes a huge difference when you're trying to think about, the idea of that completeness and what do I do to make sure that we're really ready to work.
Right, exactly. So another one that's real common, and we look at XPath expressions, right, as we move into slide 8 here, and we look at, and this is the one that that was killing our import, right? And this is doing an empty check. So we want to parse an integer from a string, and you have two choices here, is you can just straight try and parse the integer from that string, assuming that it's a perfect string that came in and that
Right.
function would work, or you do a quick null check because you know that the parse integer function will fail on an empty string, right? And it's likely that someone might give you an empty string, right? And that shouldn't
Right.
kill your process. But for us, that was a simple thing that brought us to our knees. And we
Yeah,
were
somebody
able to
forgot to
fix.
put in the street number, right?
Yeah.
And it wasn't validated
Yeah.
on the input in a different system, right? We didn't control it, but here we were missing a piece of data that
Right.
we need to go get. It clearly needs to be fixed, but it was actually causing the import to stop because people just assumed that the data was going to be good.
Right. So, it was a quick fix to say, hey, we need to do this and to go around. And this is one of the things that, the ACR tool checks for is if we're doing proper empty string checks, right? So
That's amazing.
those things help. And so this has really been helping our defensive programming. And the last one on here is it's really more the XPath retrieves. And this is less so defensive and more so about optimization. But, the order in which we put our constraints, the idea is that you want the first constraint to give you the most bang for your buck, right? And so
Okay.
it's kind of
Sure.
like doing, your queries, right? You want to have less and less every time. And so the idea is putting, things in a proper order to ensure that your queries are more optimal.
And it does then, so that is optimization, but then it's also defensive because you're trying not to overload your application, right? So
Right.
I get that. As you think about XPath, is there anything in Mendix, especially because it is heavy XPath driven, where you really have to be careful on syntax or how you're writing an XPath so that you don't, for example, turn that into something that brings your application to its knees?
So, your syntax, Studio Pro is good at checking your syntax on your XPath.
Okay.
So it won't let you go any further if you have bad syntax. So no worries there. But it's likely, you'd have to look at how much data you're bringing back in your retrieves, right? And you may have to
Right.
break them down and batch things up, right? The way that the reason why we use the process queue is so that we don't pull 100,000 objects in one list and iterate over them in one transaction because, something's going to go wrong, right?
Yeah,
We're gonna
right,
run out of
no
memory.
doubt,
The app
yeah.
may need to restart. Something's going to happen.
Right.
So, we batch things up and we queue them in groups of 10, 50, 100, whatever makes sense for the thing that's happening.
Right. I think that's a good point. And that's not really, because we talked earlier about don't focus on early optimization, but you do have to think about how your app will be used. I think back to one of the partners that we work with, and we had, not very many agents, and it listed all the agents on a page.
Yeah.
And then we had several hundred agents, and it listed all the agents on the page. And then we had a couple thousand agents,
Mm-hmm.
and it sort of listed all the agents on a page. And all of a sudden, that ability to show all of our agents when we hit, 2,500 was like, oh boy, this takes 6 minutes to come back,
Cool.
right? That was one of those things where it was some part optimization, but it was also just in the way that it was being designed.
Yeah.
And again, that goes back to what we talked about and touched on as a key point. Understand how things are going to be used so that you're designing it the right way. You don't want to show a continuous list if you're going to have, 100,000 things. You
Right.
want to be able to search that list somehow and filter what it is, because no one's going to go through 100,000 things. They're probably not going to go through 100,
Right.
but you need to think about what that looks like and actually build. And I think that goes back to the key piece of correctness. Build it so you're actually finding a way to do what you were trying to achieve the best and the most right way at the time. And obviously some of those things change and you refactor, and maybe when you started you only had 20 people that were ever going to be shown on that page, and then it grew and you suddenly have 200.
Mm-hmm.
Okay, well, take the time, go refactor that, right? That's a lesson learned. That
Yeah.
means that
Well, you
whatever
do-
you did, you probably did right.
Well, if you're doing it right, you're not doing more than you need, right? So it's not more optimal than you need. So if you're building for 20 people, you're not designing for 20,000 just yet. That may be overkill
Right.
for you, right?
Yeah,
So you have
for
to
sure.
do what's the most optimal in the moment. So, but that moment changes, right? And then when you look at it, when you had 20 agents or 100 agents, you probably had a handful, half a dozen people looking at those agents. As you had hundreds of agents and thousands of agents, you started had tens of hundreds of people supporting those agents. So now there's more people pulling that
Right.
large agent list onto the page at the same time. So as you said,
Sure.
now you're really taxing your database hard. And again, you get brought to your knees because someone wants to refresh a page, or 100 people want to refresh a page.
Yeah, or everyone logs in all at the same time
Mm-hmm.
after, you deploy something new, or you have a certain day of the month where everybody goes and looks at things. Yeah, for certain. And I think that kind of brings me to another topic that you and I talk about, in the idea of how do you fail gracefully? So let's say you do get to that point where you now have 300 people that are using your app, and they're bringing back 100,000 people, and they all do it at the same time,
Yeah.
and the app fails. How do you think about that idea of failing in a graceful manner so your user's not just stuck with sorry, something happened?
Yeah, that's tough, right? I mean, you could have a fun, whimsical, sorry, something happened, right? And just to kind of lighten the mood. We see that sometimes.
That's right, the fail whale.
Right?
Yep, for sure.
Right, so that's there. Then we talk about things like horizontal scaling and things like that, so that there's very little of that downtime. And if something fails, something can pick it up. Something can pick up the slack. We can have someone else who's standing by to take over, right? And it's about it's about minimizing that. And that's another way. It's more of a defensive infrastructure, right? And less so in the programming. Of course, your programming has to be able to support the infrastructure. But that's another way to look at it, right? I don't know a better way to make it really graceful, other than knowing it's going to go down and then being able to recover quickly.
Yeah, and I think, in that sort of situation where you may have outrun your current resources, I don't know that there is a lot you can do. But you do have to be thinking about what happens if I try to save a page, like I'm letting a user make a data change.
Mm-hmm.
What do I do there if that data is bad, right? Somebody decides that they're going to put in some JavaScript in a text box. What do I do, right? What do I say, as opposed to, just throwing up an error, like, oh, sorry, something happened and it's bad. Don't do that. How do you then think about the application dealing with that sort of bad input, or I don't want to say malicious behavior because that's a little different, but just your user, they thought they had copied in data from a website and they got all the HTML behind it and they're pasting it into your form for a note or whatever, and you can't do anything with it. So how do you think about that?
Okay, I get it. I was thinking more catastrophic. So in a less catastrophic scenario, I think you have good feedback to the user, right? There's this generic an error has occurred that can happen in a Mendix app, right? And you don't ever want your user to see that, because that means they just received an unhandled exception, right? There should be some kind of information, something they can take to some support person to say, hey, error, here's an error code, whatever, go take this to production support and tell them you just received this. They can look up that error code, know what it means, know what to do, know how to resolve it, know who to call, right? So then the user is not stuck. Because I think the idea is the user just can't be stuck and helpless. It has to be, okay, we've detected something's gone wrong. It's not working as we expected. And here's what you can do. And here's what we're going to do. And here's how we're going to make it better, right? And having that, I think that's just good user experience.
I would agree. And I think in a lot of cases, wherever you can, behind the scenes, write all the log information you can about whatever it is that went wrong, so that the support people or the developers, when they're reviewing logs later, can see it and say, oh, there's a whole bunch of stuff in here. We were expecting you to have typed in some notes and you have, 3 pages of HTML. I don't think that's what you meant. We only, gave you 255 characters and you put in 20,000. That kind of thing. If you can tell, obviously, right up front what happened with some sort of, client-side or server-side check, then obviously you just want to give back, hey, maybe that field's too long, and do that. But in areas where it's not as obvious, I think you need to write some sort of detailed log that can help, that's an actionable log, that can help that person behind the scenes actually get in there and do something. So it is, you're right, error handling and just not showing this whole thing failed.
Right.
Something else I wanted to talk about that you had mentioned a little bit about, data import. One of the things that we've done, which I think is a great way, and I'm sure other people do it, but as you're thinking, even in a low code environment, we import data, and we import a lot of data. Yeah. And we actually built a mock service for one of the third parties that we use, so that in our performance testing, we could simulate, 100,000 records being imported. But the other thing that gave us was the ability to create that data that's really good and all clean, and that data that's all really bad, because we can just go mess it all up, and then kind of a mixed data set, so that we now have a way, we've built a mock service of data that we can take and either turn into, a performance thing, or use it to test how does your application, the functionality that we're building around this data import, how well does it really work when the data is more realistic and uncontrolled?
Right. And that was a good concept and good idea, because it was something we weren't doing, right? It was like we assume everything to be perfect all the time. And so when we build test cases and transactions and we push them through, because we're testing the code, and so we don't want the data to make us feel like the code's wrong, but it really is wrong if it's not handling it. So we're making sure the code does what it does in a happy path way. And then it's about how do we throw now a bunch of garbage at it, right? The worst things we can think of, all messed up, and see how it handles it, right? Now, how can we break it and say, okay, let's get past this? And it's like every time we have to let it get through a set of things, and new things will come up. We can't think of everything all the time, but then we add that to the data set, and we just say, this is part of our regression, is you can deal with all this garbage. And every time we find more garbage, we'll add more garbage to that test set and keep passing it through.
That's been one of the best parts, right? As the vendor that provides that service to us, as they make changes or they add new fields, and we find ways that the data's not necessarily what we expected.
Right.
We go back and we add in garbage data into that mock service. So again, for people that are listening, that's not a low code thing. That's just a help yourself be defensive. Give yourself bad data to go choke on. And when the app can handle all the bad data and it still works and it still fails like it's supposed to, you're doing something right. Like that's a great day. I know when we, were able to import all of that data and not have the process queue fail, that's going to be a pretty amazing day for us. I don't know that we're there. I think we still see that every now and then. We have some things that fail, but it's a lot less likely. It might be once a week, not a couple times an hour where we have bad data.
Right.
So it's an improvement.
And that's a good point too, because it's not always, bad decisions we made. Things can change without our being, made aware of it, right? Like those things just happen. And so then we're like, oh yeah, a new field was changed in this version of the API or whatever we're using to get data, right?
Right.
And or this data type changed and we didn't even know. And so it's like, and that would be the defensive programming on the vendor side to maybe version that out, right? Or something.
You would hope,
notice, instead of breaking us all immediately, right? Because that's huge.
Yeah, and again, that's not a low code feature, right? That's everywhere. You always get that, but then your preconditions have to change. The things that we've set up front, where we're expecting this to be a value between 1 and 100, and suddenly we're getting 986.
Right.
Well, something is different, right? Like if it's never been outside of the 0 or 1 to 100, what changed? Did the vendor change something? Is there a new feature? You would hope that those kind of things would be either done well in advance, so and you can test it and you can be prepared. But when it's a third party, you don't know. But if you think about for us in a microservice environment, we do have to consider that. If we've made a contract and saying we're putting out data that's like X, Y, and Z, and then we're going to change it to add in W, X, Y, and Z, that's a version, right? We have to announce that. We can't just go change it and expect that our consumers are going to really, be able to handle that without all sorts of issue. You and I talked at one point as we were working on kind of the whole framework for microservices about cohesion and coupling.
Right.
And the differences there. Right. So the cohesion for those of you that maybe aren't familiar is how much do things relate to one another, right? And you want objects to relate to each other. And then coupling is how much are they dependent on one another, where a change to one has a potentially negative impact on the other. As you think about those two things, how does that play into your defensive programming if at all?
It definitely does. And so we look at coupling for sure, right? Because that makes apps dependent on each other, and it makes it hard for us to deploy or even test properly or things in a modular way, right? And so we want to loosely couple our apps so that they can kind of dance on their own. And when we look at within each component is how much do they relate to each other within the component, right? And so when we look at that combination of or that domain-driven design, right, and that event-driven architecture. And so when we look at those things and we apply them to a microservice architecture, it screams of both cohesion and loose coupling, right? And the idea in the defensive programming is you want to move to a looser coupling situation. We have a lot of tight couplings in situations where we needed them, or where it was the best choice in the moment because something else wasn't available. And as things become available, we are moving things more into this looser coupling, event-driven versus a lot of direct API calls and things like that. So, those things, they definitely come into play very much so as we think about, all the design, and it's at the core of everything we do.
I think you're nailing it today, right? Thinking about what you have to do in the moment, because things may change, right? We talked, in a previous podcast about be present in what you're doing and in your life. But when you're writing code, if you're spending time thinking about how it's all going to change or might change, and you're trying to future-proof yourself, you're doing it the wrong way, right? Now you have an astronaut architect. You're like, hey, I need a form that'll capture an email address. And they're like, okay, well, are they on the moon station or on Mars?
Yeah.
No. I just want to get an email address.
Just an email address.
Right. So while they're in space. No, I don't need it to work from the International Space Station. Oh, really? So what's the real requirement then? Right? If you're spending so much time on that, you're probably going to be paralyzed. I think your point of what's the right decision in the moment, and know that you might come back and do it different, right? Maybe, the next time you're going to say, well, yeah, this wasn't a great way to go. We coupled this, or there's the cohesion here is terrible and it's tightly coupled. All right. Well, then you go back and you refactor and you use the new information you have to build it in a different way and do, take a different approach and make it better, improve your user's experience, improve how you're being defensive. But you don't have to get it perfect to get better, right? And I think that is something that you and I talk about a lot is don't let perfect get in the way of better.
Right.
And it is that same sort of thing comes in. You could spend all day being defensive, but there's only a benefit to so much of it, right? I mean, if you think about defensive driving, the best way to be a defensive driver is don't get in the car and don't leave your driveway.
Right. Yeah.
But it's not very practical.
No, won't get you anywhere.
So you could write regex to check every piece of data for every sort of thing and make sure it's always perfect. But it's probably not processor intensive, and it's probably going to be a horrible experience for your user and for the developer.
Right.
So you have to find, based on the information, do the right thing at the right time for it. Not just in the defensive part, but in the whole development, effort that you're doing all the way around.
Right. There has to be a balance of it. You can't be too much on one side or the other. And you have to be very situational, and it requires exactly that, being very present to know what's happening around me right now, and what's the course of action we got to go on, right?
Yeah, and I think if you pay attention to how your users are doing things, the things that might come into your production support, or if you have some sort of logging built in or an error handling program that, rounds up data for you, if you're looking, you'll see the places where there's problems. And then you just have to make the time to go and address them and fix them in a way that, they're either resolved or it's just, it's handled better so that your users can fix whatever they need to and move on. I think early on you mentioned don't leave your users stuck.
Right.
Because that's a pretty awful feeling. How many times have you been on a website where you're trying to fill something out and it's like, no, you can't get there from here. The buses don't work. I'm sorry.
Yeah, no, that's frustrating.
Everybody's been there, right? Everybody listening to this podcast has been in that situation, and you don't like it, right? And as your world's being more and more programmed, you really do have to figure out how to make it so your users have an option. Even if their option is to come back later, at least give them an option. That's not a great one, but at least give them an option.
Something better than just a no idea what's going on, random what does this mean?
Right. Right. So, we've covered a lot of ground today.
Yeah.
As you think about low code, Mendix, or any low code environment, what would you say would be your first thing you would tell someone to think about from a defensive position, right? What's like that number one thing for you?
I would say that the tenets all still apply, right? Whatever it is, all the defensive tenets, the best practices, the naming conventions, and all these things that are provided out there. And you might translate them from different languages to another. They have their own version of Mendix. Just because you're using a low-code program and the idea is you want to get through it quickly, and I know that it's called rapid application development. It literally has the word rapid in it. And when we talk about, you can quickly turn around stuff, which also means you can quickly turn around a lot of garbage. And so if you're
Right.
not paying attention as you go along, the amount of technical debt that you build up would be exponential, right? And then your ability to come back and grab it would be terrible. So just really think about what you're doing and apply those practices, right? The naming conventions, they may seem silly because it's like, oh, it's a visual thing, or I'm drawing it, or if, my line is a little crooked in my microphone, like little things like that kind of irk me. But like that is our readability. That's our concept. It's a visual language. So that
Right.
visual readability matters. It's the same as if it was coding and you have readability in your code. You're just not going to put a bunch of lines of code on one line with a bunch of semicolons in between them, right? You can at least break
Right.
it up. And then you might even have some tabs in there, right, to kind of let you know. So that's the readability. And for us, when we're making our microflows, we have our own concept of readability, and it's important to apply them.
Yeah, I would say, just as a funny side note, the layout of the elements of a microflow being straight and how you use true and false and where you go,
Mm-hmm.
and what condition carries on forward and what condition goes, branches, is really the same discussion as people who work in like Java or C# between, do you use spaces or do you use tabs?
Mm-hmm.
Right? And no matter who you talk to, the other side's a heathen. And I've been in a couple places where there was a developer who didn't even want spaces, like blank lines. So he put in whack whack plus everywhere there's a blank line.
Oh, wow.
So it's a commented plus sign all over the place. So that actually became kind of a joke because we weren't really sure who had done it, but there was somebody had checked in all this code with whack whack plus in there.
Mm-hmm.
But it is that whole thing of the style of your microflow and how it is readable is that same discussion as, do I use spaces or tabs? Do I, thinking about like JavaScript, do I put the opening bracket on the same line as the function name? Or do I do it like a normal person and put it down below?
Right.
Right? Like those sorts of things are real. And I like that you do need to apply some level of defensive thought or best practice, even though it is rapid and it is low code. You're right. You can really quickly build something that you can't then maintain.
Right.
And how many developers out there have built something and they said, hey, this is my proof of concept, and that ended up being in production for 6 years and you had to support it.
Right.
So don't, try to stay away from that. Spend a little bit of time. Hopefully you don't get stuck with it.
Yeah.
With it being your proof of concept in production for that long.
Right.
Anything else that you want to touch on today before we wrap up?
No, I think I think we could do probably a part 2 of this, going into any more subjects, but I think we touched on it all, readability, naming conventions, modularity, design, just the way you think about things, good decisions, checking for bad data. I think, there's a wealth of information on here. We didn't tie a lot into error handling too much other than just making sure you're handling errors. We didn't even talk about logging and things like that and troubleshooting the app and other things, but we did go through a lot today.
Yeah, I think you're right. I think that would be a great follow-on, is the troubleshooting piece and how do you write actionable logs. For those of you that are listening, if there's a topic you would like more information on, we'd love to hear about it. Feel free to reach out. Comments on YouTube or on our website, wherever makes most sense to you. You can always reach out. As always, show notes will be available online. Imran's put together a pretty amazing slide deck to share with everyone. That'll also be available. And then, just really like to thank you all for joining us during this great conversation.
Yeah, thank you. We'll catch you all next time.
Thank you for listening to this episode of The Architect and the Executive, a podcast by Imran Kassam and Steve Ledwith. We hope you enjoyed this episode and encourage you to subscribe to our channel on your favorite podcast platform. All of our episodes, show notes, and articles can be found on our website, thearchitectandtheexecutive.com. Thank you.